Now we will discuss primary index in detail. So when I say we are discussing primary index, that means the data will be having ordered data and it will be having key values. So data will be sorted in either ascending order or descending order, plus it will be having unique values. So we will take one example and then we will understand how primary index is used. Suppose I have a database table with the name book. Now the table is having attributes book number, name, author and ISBN. We have 4 columns in the database table book, and book number attribute will be declared as the primary key. So in some DBMS softwares like SQL Server, the moment you create any attribute as primary key, that attribute will be declared as your search key in the index table automatically. So in some DBMS softwares, the moment you create primary index, so in some database softwares, the moment you create primary key, the primary index is created automatically. So in this table we have 4 attributes. Now how the data will be stored in the disk blocks, we will see. So suppose this is the hard disk, we have different blocks in the hard disk, and in each block we will be keeping 4 records, for example. So here I will keep, this is block number 1, block number 2, block number 3 and so on. In block number 1 I am keeping 4 records with book number 1, 2, 3, 4. In second block again I will keep 4 records with book number 5, 6, 7, 8. Again in third block I will keep 4 records starting with book number 9, 10 and so on. So in each block we are keeping 4 records in this example. Now we will maintain a index table also. As we discussed, index table will be having 2 attributes. One is search key and the other one is block pointer. So if we have created book number field as the primary key of the table, then book number will be the search key also. Now here you can see whatever book numbers we have, for each block I will make one entry in the index table. So suppose in the block 1 I am having 4 records. So for all these 4 records I will make one entry in the index table with the search key 1. So this value 1, which is the book number, will be called as anchor record because it is acting as a leader and this single value is representing the whole block in the disk. So we will make a single entry for the first value, which will be called as the anchor record. Again for the second block, which is having these 4 values, I will take the first value 5, book number 5, and I will make a entry in the index table. Again in the third block we will be having 4 records. So the first record will be starting with the value 9. So 9 will be considered as anchor record, and for all the 4 records I will make only a single entry in the index table with the value 9. So basically what we are doing, for a complete block we are making just a single entry in the index table. So this is known as sparse index. So in sparse index, for individual block we will be making a single entry. So again 9, 10, 11, 12 and for 13 onwards I will make another entry. Like that, in our index table we will make a single entry for individual block, and the block pointer will contain the address for the required block. So if I want to access the search key 1, the block pointer field will be containing the pointer that will point to the block number 1. The second entry will be having the pointer which will point to the block number 2. Third entry will be having pointer that will point towards block number 3 and so on. So when we have single entry for the complete block, we call it sparse. We call it sparse. Now we can do individual entry for individual record also. So if we have these records in the disk block, instead of making a single entry for the complete block, we can make individual entry for individual record in the index table. So for that, for 1, 2, 3, 4 individual entries we will make in the index table, 1, 2, 3, 4 like that. So individual pointer will be pointing to the individual records in the disk blocks. So managing pointers will become very complex in that case. This is known as dense indexing. So primary index was having two variation, sparse and dense. So in sparse, whatever number of blocks we have, that many entries we will make in the index table, but in case of dense, we will make individual entry for the individual record, which will make managing the pointers, it will make it very complex. So usually primary index, we created a index table. We created an index table with two columns, search key and block pointer. For individual block, we kept only one entry. Now suppose I am looking for a record sparse. Select star from book where book number is equal to 3. Now when I execute this query, the processor will see that book number is equal to 3. Now that means 3 is greater than 1, but it is less than 5. That means the record with book number 3 will be stored in this block. So this pointer will be pointing to that particular block, and in that block we will find the required tuple with the book number 3. Again, if I am looking for book number 7, so book number 7 means 7 is greater than 5 and 7 is less than 9. So that means the required record is present in this block. So this pointer will take us to the required block. Now this block will be transferred to the main memory, and from this block we will access the required record which is having the book number 7. So in this way, if we are maintaining a index table for the database files, the input output cost is minimized because we are transferring only few number of blocks from secondary memory to main memory. So this is how indexing is helping us access the required data in a faster, in an efficient manner. In the index table, I am performing nothing but binary search. I am performing binary search in the index table, and based on the required pointer for the block, we will access a particular block in the database file, and that block will be transferred to the main memory and we will read the required record. So the time complexity will be log base 2 n This is for binary search that we will perform in the index table. Now once you will find the required block, in that block you will reach the required tuple also. So for that plus 1. So log 2 n plus 1 is the time complexity that is taken by primary indexing for processing the, for getting the desired data, where n is the number of blocks in index table. Got log base to n plus 1 complexity because log base to n we are performing binary search on the index table. After performing the binary search, we are reaching the desired block. Now after reaching the desired block, we are either performing read or write operation, so plus 1 for that. So total log base to n plus 1. So in this way we are minimizing the time taken in order to reach any record in database file while processing any query. So see, if the primary indexing is done in dense manner, the number of entries in index table will be equal to the number of records, and for sparse the number of entries in index table is equal to the number of blocks. So if we make it dense, then the complexity will be more because multiple pointers will be there. So handling all the pointers will become very complicated. So usually primary index is done in sparse way. Now here are some points to ponder. First we discussed file organization. So file organization is the process of mapping database records onto the disk blocks. This can be done in ordered way or unordered way. So we discussed sequential way and heap file organization. Then we discussed indexing. Indexing is used to reduce input output cost that can be done if we minimize the number of block transfer in the main memory. Thus we can make the data retrieval efficient. Then we discussed primary indexing in detail. Thank you.